at that time, just a quick little, we can get into Gauss too. At that time, the Big Bang wasn't really a very popular thing. There were two popular theories. The Big Bang theory, which proposed that, well, things had started from something smaller. And do remember, the Big Bang didn't really have a lot of scientific at all evidence to it, because it was just actually invented by a news reporter. He was
he was...
No, of course, he was paraphrasing a scientist, but the actual science behind it, it was just an idea. It's like, hey, listen, what if the universe is expanding from something smaller because we can see it accelerate, so it had to have come from something smaller. Deducing Hubble's observations, we can get to, hey, maybe the universe started with something smaller and it's now this.
Wait, here's a quick question. If you look at any galaxy, like in the sky, any arbitrary direction, are there any galaxies that are accelerating towards us?
Yes, Andromeda.
Oh yeah.
Yeah.
Yeah, that's true.
So it all depends.
No, but like I'm talking like not in our local cluster.
No, because the whole point of the universe's expansion is that.
No, but I know. But can you is there one that's not in our local cluster, but like still accelerating towards us?
By the laws of dark energy and what we understand about the universe, no. Because the whole point of it is that it's like a balloon, and it's like the balloon analogy. Two things, no matter how, they're always gonna get farther away, right? Unless one is already in motion, which is probably
maybe not accelerating. What, just like traveling
towards us? I think that's possible.
That's possible.
I think that's possible. I think that's possible.
Sure.
Anyways,
I would expect though that most of them would be like redshifted down.
Yeah, most of them are. Then that's what he sees. And you see, the farther away you are, the farther.
This is why
and that's the crazy. The farther away you are, the faster you accelerate, which should not. You know what I mean? So that means that the universe is accelerating. Anyways, now this guy, Stephen Hawking, PhD. So he's doing his thesis. He's doing it in the works of cosmology and general relativity. So he has a good. He was actually called the Einstein of his undergrad, I believe. So a little interesting there. And he was. I mean, at that time, black holes were mildly understood by the general theory of relativity. It's like, hey, there is this gravitational influence on this one part of space that's infinitely curved, and as a black hole is being formed, well, the singularity, well, there's more mass that's being kind of brought into this one point, and when there's enough mass that breaks this critical mass, it's now a black hole. So he's like, wait a second, what if we reverse the process, and instead of a black hole collapsing or a star collapsing into a black hole, what if a black hole kind of started a star?
I have an issue with that.
That original idea was not actually what he went with.
Yeah.
What he went with is, what if we approximate the black hole to be the universe? And this is where it got crazy. Because with Roger Penrose, the original stater of the Big Bang, with like the inflationary model of the Big Bang, both of them released the paper, and he actually, this was his PhD thesis actually on the universe being modeled as a black hole. And what he did was he mathematically showed the universe's starting point as a singularity. And as it expanded, he basically showed how the general theory of relativity still matches up with what we understand. So he used the field equations to basically show that the Big Bang is our most accurate model that we have today. So when people say the Big Bang is a theory, yes, it's a theory, but with what we know about general relativity, it has been proved. And that proof was done by Dr. Hawking himself.
Wow.
Yeah.
No, that's crazy.
That is pretty crazy. Right? Just try to think about that.
When you were talking, I was thinking about how cool black holes are, and I want to do another episode on black holes.
Black holes part 2.
But like, I don't know what we talk about, to be honest.
We talked about a lot of things.
We did talk about a lot
in the
of
very
things.
first black hole episode.
But man, black holes are just so cool. I remember I explained how when you're going towards a black hole, it starts as a point. And then once you pass the event horizon, like your entire universe is perfectly like 50% black, 50% universe. And then the more, like the further you get into a black hole, the more the universe contracts into a single point, and the rest of your universe becomes black. crazy.
Bro,
Such a
black
crazy.
holes itself have a whole. I mean, black hole physics is a thing of itself. It's a field of itself. And Hawking basically, I'm not gonna say invented, but he fueled the invention. Because a big thing that he also did was literally black hole mechanics. That was not a thing. Black hole dynamics, black hole mechanics was not really a thing, and he basically invented it.
Such a
with
scary
thermodynamics.
topic.
I know, like how do you, right? So with thermodynamics, and now we know and everything like that, he used that to basically apply it to black holes to make laws, like with other scientists. Him and I believe 2 other individuals, they proposed the laws of black hole mechanics for the very first time. So just very, very in-depth into black holes and cosmology. And do remember, at this time, and even now, I mean, not that we know much, but black holes were highly theoretical. The only place that they really existed was on paper.
Yeah.
Right? We hadn't even thought about observing one of these things.
I have a crazy question.
Let's
and
see.
feel free to answer this question if you're listening to this right now. I would be genuinely curious to see, like, what percentage of the population, probably not a lot, but would you, if you had the option to be like, okay, you get like another 10 years on Earth, but 10 years from now, you have the option to be thrown into a black hole. Would you do it? Like, crazy experience.
Why are we? This is
Crazy.
the dumbest question, though. Like,
would you not do it? I would do it.
Thrown into a black hole?
What? That'd be the craziest experience ever.
You're gonna get you're just gonna die immediately. I mean,
Okay,
not
no,
really,
you're
but,
like you're going to die. But first of all, you're gonna be the first person to ever go into a black hole. Second of all, you don't know if you're gonna die. What if there's a tesseract? What if there's the whole time travel thing?
Not a topic of today's discussion, but definitely a cool.
But would
cool
you?
thought.
Would you? Yes or no?
I mean, you said like I'm already at the end of my life and the kind of thing, and like I'm already dying, so I can.
No, 10 years from now.
Oh, 10 years from now.
From now.
You would do that? 10 years
I would
from
consider it. I would
now?
consider
I would not
it.
do that. No, I want to live my life here on Earth.
A black hole though. Like it
Anyways.
includes the trip and like you get to see the universe,
Okay,
you know what I
cool.
mean?
Anyways, point being that Hawking was very crucial in parts of black hole mechanics.
No, for sure.
And because at that time, the Big Bang theory and the steady state theory were the only 2 ones that were really there. Like steady state being that the universe had always existed and will always exist, right? But the inflationary model had some backing to it, but not many people were convinced, which is when he kind of came up with this mathematical reasoning, posted it as his thesis, and well, now we know.
Thinking the universe is flat and infinite is so like it seems so like simple. Like it's too simple of an answer. Where does the universe come from? It's just literally always been here.
But
and
you have to
doesn't
understand at that
change.
time, like there are no ways to measure and no ways to really think about anything apart from us.
Wait, there wasn't redshift?
Oh yeah.
Back
Hubble,
in the
Hubble happened.
Yeah,
happened
Hubble.
before this. No, but steady state also explained that because you can just have individual galaxies moving away. Because remember, like the observations weren't very heavy at that time.
Yeah.
Like it wasn't like we have catalogs and trillions of stars.
But it still seems like at the time you could just be listening to the scientists say these things and be like, really? We're going with eternal.
We can't say that.
That's the
then.
answer.
Anyways, that's a little bit of Hawking
Yeah.
and how he started his postdoctorate career. Definitely cooler things, and I think you already know what's coming up. I mean, who
What
doesn't?
about Mr. Gauss?
Let's move on.
I don't
to
think
Gauss.
he's a doctor, to be honest. I don't.
No
think
way.
I mean, this was in the 17s. I don't know. Anyway,
I guess Isaac. Wait, when was the philosophy?
I don't know.
When was Doctor of
when was
Philosophy?
Doctor of Philosophy a thing?
Like, when did it start?
Because it had to start at 19.
No way. No.
That's not true. It's a 1998.
It was
Like,
when was HD invented,
Oh.
not PhD, like high
Oh,
definition.
that's funny.
The first doctorate degree was granted in the
12th?
12th
Okay.
century. So he could have definitely got one.
Yeah, for sure.